Hello, and welcome to the video lesson on writing equations of lines using point-slope form. This should be hopefully a review and a practice, but this is a skill we definitely want to get better at. So we are going to start by thinking about slope in terms of rise and run. If we look at the grid, the rise is pretty easy to calculate, and the run is also easy to calculate just by counting what the change is vertically and what the change is horizontally. And so if we go vertically from left to right, 1, 2, 3, 4, 5, we are increasing by 5, rising 5, and running 1, 2, 3, 4, 5, 6, 7. So those will be our numbers that we'll use for the rise and the run, which essentially reflects our slope. So we're rising up 5 and to the right 7. If we'd have said down or left, we would have made those numbers negative. But 5 over 7 does not reduce, and so our slope is just 5 over 7. Notice I did not divide the slope because no units were provided on this particular problem to help explain what this slope is representing. All right, so our slope is 5/7. Let's confirm that using our ordered pairs. If you look at the diagram, the first point, which is right here, is the ordered pair -3, -3, because we're moving back and down. And the other pair is 4, 2, 4 to the right, 2 up. So if we use our formula, we just have to decide which one we're going to call x1 and y1, and which one we're going to call x2 and y2. So I just chose the first one as the ones and the second ones as the twos. And so this one will be x2 and y2. Okay, so our formula is set up for us to use. Formula says take y2 minus y1. So I chose this to be my y2, and I'm going to subtract -3 from that. So the numerator will be 2 minus -3. And then when we go to the denominator, we're looking at the x's. So 4 minus -3. So down here we'll put 4 minus -3. And when we go to simplify now, we know that 2 subtraction signs actually is the same as adding, because we're really taking the opposite of a negative. So we're going to take 2 plus 3, which is 5. And in the denominator, we're going to turn that into 4 plus 3, which is 7. And if you notice, that is the exact same thing we came up with using the formula earlier. Okay, so we got our slope. From the ordered pairs, we just have to choose one that we're going to use. And so since I chose the first one to be x1, y1, that will also be the point that I plug in. This ordered pair will also be what we use to plug into the formula. If you chose the other one, that's fine too. You just have to make a choice on which one we're going to use. All right, so I've picked my point. I have my slope. I'm going to record my slope down here, 5/7. And now we just play the substitution game. So let me switch pens here. Our formula says we're going to take y, using this one here. We're going to take y minus the y1. Well, my y1 is -3, so I'm going to subtract -3 from y. All right, now moving on to the right. M is our slope, and so we're going to use 5/7 instead of m. X is going to stay, and x1 is the x coordinate from the ordered pair, and that it was also -3. All right, so now that we have it written, we have 2 steps left to do. One of the things we're going to do is distribute, and once we finish that, we'll try to get that y isolated. So if I simplify my expression, I have y plus 3 equals 5/7 times the quantity x plus 3. Okay, our first step is to distribute. So since I'm not doing anything to the left side, I'm going to go ahead and just copy that down so I don't forget about it. And then we're going to distribute 5/7 to both of those numbers. So when we go to distribute the 5/7 to x, we get 5/7 x. And then 5/7 times 3, I'm just going to work that off to the side, ends up being a positive times a positive will make this positive. So we'll get 15/7 for our value there. Okay, now, to get y by itself, we're almost done. We just have to subtract 3 from both sides of the equation. So we end up with y is equal to 5/7 x. And in order to add or subtract fractions, we need a common denominator. So if I put a 7 in the denominator, I also have to put a 7 in the numerator. So this is going to simplify to be, let me do that a little cleaner here. This is going to simplify to be, work this off to the side, 15/7, which was positive, minus 21/7. And if we simplify that, we get -6/7. Okay, and let's just check back up on the graph to see if that seems reasonable with the graph. So let's just see, -6/7. Well, my y-intercept on the graph kind of looks like -1, but that's just an estimate when you look at it. We can tell when we do our calculations, the actual y-intercept was -6/7 instead of -1. So our final equation will be y is equal to 5/7 x minus 6/7. And that is the equation of the line.